We borrowed, yeah. So we borrowed from all the talks. We're going to refer to a lot of stuff that Charlie spoke about, and of course a lot of stuff from Derek's domain, because this is kind of our domain as well. The complex systems and fighting fires from Andy, and great talks in 3 pieces from PJ. We actually have it in title. 3 pieces. This is me. My name is Baruch. I'm a developer advocate with JFrog. This is Naren. He's a solution architect with JFrog. We are here on Twitter, on the internet. We have it on every slide, so you won't miss it. Greek tragedy, you know how it works. We have a prologue. We have 3 acts. Everybody die, and that's about it, which makes a lot of sense when we are talking about DevOps at scale, right? It cannot end good. You know that. You're here for that reason. So let's start with the prologue. And the prologue, of course, is the question that every DevOps conference in the world, half of the talks are about that, or at least used to be, now less, but we will bring this great tradition back to talk about what the hell is DevOps. And I guess we have a lot of different aspects to it, and all of them can be explained in Venn diagrams, right? Because everything in the world can be explained in Venn diagrams, including what is DevOps. So I will show you 2. The first, of course, you know, that's the canonical DevOps thing. When you have devs, when you have ops, you blend them together, you get DevOps, and somewhere in the way we forgot about quality at all. So after we already had this name and run with it for a while, we're like, wait a second, what about QA? And then we added QA, but we didn't change the name. So it's kind of DevOps, but with QA, that's the modern state of things, which is, of course, the default view, and it's nice, but I would say there is another one which is much more interesting, and this is this one. DevOps happens when process, people, and technology meet and actually change from what they used to do. And our talk today is going to be around that. So another aspect is a scale. And of course, scale is a scale, right? For everybody, it's different. Like PJ said, 40 developers in a startup, that's a huge company. And 600,000 developers in another company, that's also like big, right? So everybody takes this scale a little bit differently. And I hope during our talk today, you will find yourself relate to some point on this scale of scale. So we're going to use an imaginary company to describe our journey. It's called Pentagon Inc., and there is a lot of fun into it. First of all, they do payments processing as another company in shape you probably all know, and there is no relation whatsoever except of the being clever with names. So Pentagon Inc. is our company that we are going to our journey of scale. So first act of our Greek strategy is called Fire Brigade, also known as reactive ops. So we need to set the stage before we get to action, and we will start with the description of people. You remember people, tools, processes, so let's start with people. And we're talking about a startup, and it's just an idea with 3 developers are trying to revolutionize the world of payments, or should I say disrupt, right? Or should I should I say inspire? Whatever, you got the idea. All of them are good developers. They came from on-prem background, all of them, defense, Pentagon, yeah, this clever name again. And they are smart people. They know technology. They've been in that for years. And they kind of do the right thing. So they're a little bit of hipsters, kind of, you know, the trendy way, like PJ mentioned. So they use stuff like JS and Node and reactive and microservices, all the hype that is now very, very current. Now, for the process, again, they are both smart and a little bit of hipsterish. So again, they do the right thing, what the industry does today. So they use Kanban for their development. And if you ask me, if you ask Narina, I guess we agree that for this size of team, that's the right way to go. QA, well, again, the guys know their stuff. So they do test-driven development. They have unit and integration, automated tests. Everything is covered, good code coverage, and they can actually feel that their code is reliable. They can actually rely on what they wrote. Well, for ops, you know, in today's world, we don't need much ops. We have two great trends. One of them is called serverless. We don't need any servers, which brings us to the next one, which is called no ops. If we don't have any servers, we don't need any ops. And you all here as a DevOps conference should agree right now, right? That makes perfect sense. Well, you know what? Maybe for 3 people it actually does. So in tools, they use something like Jira to manage their Kanban boards. Of course, the source, GitHub, it might be Bitbucket, it might be GitLab. Well, actually not anymore, but until next week it could be GitLab as well. Travis CI or any other server, cloud CI server. Who knows Travis CI? Well, not so much. Okay, so Travis CI is a CI server. Who knows what CI server is? Guys, you're scary like the shit out of me. Seriously? Okay, Jenkins. Okay, so Jenkins is a CI server, all right? And Travis CI and Drone and many others are other CI servers which are in the cloud. They are services. They watch your GitHub repo or your Bitbucket repo or GitLab repo when it's up, and then it builds whatever is there, right? So Travis is a good example, many others. And then they use a platform as a service in the cloud, something like AWS Beanstalk, or of course there are others. Our friends from Pivotal are here, so Cloud Foundry, of course, should be mentioned. And there are a lot of platforms that you can deploy your code into, and it will run there. As I mentioned, serverless, we don't manage any servers, and pretty much no ops. Just deploy my code directly from my CI servers. All of them have connectors to all those platforms. Heroku might be another one that you might have heard. And then it just runs. Okay, makes sense? So far, so good. This was the stage, and now let's jump to action. Well, first scene of our first act is waiting. Those 3 guys wrote their platform, and now they wait for their first customer. They are in Silicon Valley, they go to some socializing events, and eventually they meet some kind of celebrity that runs a fashion brand under their name, and they decide that they will give these Pentagon guys a chance, so they have a first customer, and then, of course, this happens. As PJ mentioned, when we have some money in, first thing we drink. So this is exactly what those 3 guys do as well. They drink, and then, of course, Friday night, I would say like what, 2 or 3 a.m., everybody drunk. A call from a customer. Nothing works. Your platform is down, right? And they just signed it. It's like first week or something. So, of course, this is the obligatory reaction, naturally, but then they charge. Right, and as I mentioned, they are smart kids. They know what they are doing. So everybody have root. They're just 3 developers, and they actually log in to the production system, to AWS or whatever, and start to fight the fire. Right. So first, they need to look at the logs, and where are the logs? It's not their server, and the microservices means they have tons of different logs, and all of them might end up in different time zones. So there is an event in 1 a.m., but it correlates to some other event in 5 a.m. How they are even connected, how can we do that? right? So eventually they find the root cause, and what they discover is that during this great drink up celebration of their first customer on Friday night, one of them did some commit because he just thought of a great idea right after a couple of dozens of beers probably, and they just write it on, committed it, and as you remember, it went directly from the source through the CI server to production. Well, that's unpleasant, but sounds like trivial to fix. All what they need to do is find the previous, it's unroll this commit, find the previous commit, and build it. It's not like a rocket science. The problem is the build doesn't run anymore. It was just fine on Thursday, but it won't run anymore. What happened? Now, this is again something that PJ already referred to. How many of you have heard of unpublished gate and left pad scandal a couple of months ago? Well, it was a big deal. Some very popular library in the JavaScript world that pads your text from the left was unpublished, was actually deleted from NPM central repository, from NPM registry. And then all the internet broke. It broke because how the registry works. It not only checks if you need a new dependency, it also checks if one of the dependencies that you used are still available, and if not, it breaks the build, which is kind of a crazy idea, but this is how it works. So a build that ran perfectly fine on Thursday won't run again on Friday. Well, long story short, they eventually manage somehow to fix it. They find some old backup of this library that they needed, and they use it somehow from their local file system inside Travis. Dirty hacks, eventually they did it. The sad story about it is that in this way or another, those incidents happen almost every week. And they wish to put in place some controls and checks and something to stop running after their tail, but they actually can't because they need to firefight what's going on, right? So that's what we call the firefighting and reactive ops. Those guys react when bad things happen over and over again. And now we switch to Act 2, which is called the smoke alarm installers, also known as reactive improvement. And that's, of course, the next step. Well, so getting back to setting the stage, new in people, well, the guys raised some money. Eventually, with all the firefighting, their system was good, and someone actually invested some money into them, right? So now they have the capacity to hire more engineers. They go to 30 developers, and one of the developers actually have an ops background, right? So they have more customers, about hundreds, large and small, and they have a support team, so that kind of does the level 1 and level 2 support in process. They are bigger now, so Kanban probably won't cut. They try Scrum. Who knows what exploratory testing is? No one heard this term? What is it? Testing by sweeping around your application without any structure. Any other ideas what exploratory testing is? Well, I'll tell you what. It's just a fancy name for manual QA. Manual QA sounds bad. That's the new manual QA. And you know what? Turns out that we actually need it because we actually use the automatic testing. We write tests usually after something broke. But if it weren't broke, we probably won't know about it. So now they have this exploratory testing, and now the guys have actually ops, because there is this guy that tells them there is no such thing as serverless, and there is no such thing as no ops. Serverless is just someone else's server, but you still have it. And ops, you still have them even if you try to ignore them, right? And they have a developer on call. Now, developer on call is the one that the support team escalates to, the one that carries the pager. You know the story, of course. They solved the logging problem by moving to Greenwich. At least they considered it, and then they discovered it's almost as expensive as Silicon Valley and decided they are going to stay in Silicon Valley, but now at least they have all their logs aligned to Greenwich time, so that's not a problem anymore. In tools, now they know better. So they have some kind of a knowledge base. It can be Confluence, it can be any other, it can be a bunch of text files or markdown documents. They have some kind of a database in which the support team now look for the solution. They have GitHub Traverse CI and the same. They have a repository manager. They could go with Sonatype, but they decided to go with JFrog Artifactory for the obvious reasons, of course. And if you want to do the same decision, our table is right there. That was a very shameless plug, right? Beanstalk is still fine, right? The thing is now we need to start understanding what's going on. Some kind of a log aggregator, and Sumo Logic, our friends there, are a great example. There are others, but again, come there to hear why you need them and not anybody else. And a very early beginnings of a monitoring system. So who knows what Pingdom is? Okay, right. The same hands, right? So almost nobody. Pingdom is like the basic monitoring system you can think of. All it does, you provide them with URL, and they check it whether it's up or not. This is all. But it's better to not having anything. So at least the problem that they had previously won't happen again. At least now they know where the system is up. So that's, of course, a lot of improvements, and you can see. And now it's time to get to action. Now, in scene 1, in our second act, here, the guys, of course, drink. And now they have a good reason. They, if you remember, they have first round of investment. They have money to spend on drinks, right? So, of course, they drink. And then, of course, Friday night, they're all drunk, and there is a call from a customer. Now, this time, it's not that everything is down. That can not happen already because they have this Pingdom monitoring. They would know, but it's just something very strange happening. So let's say, for example, the Visa and MasterCard are fine, but American Express cards are not going through, right? And Pingdom cannot help with that. And this is how they missed it. So again, they go to the normal reaction mode, and eventually they charge again. Now they have a support that get this call, and they check their knowledge base. There is nothing useful there. And then they have a developer on call, who is the only sober guy in the company because he is on call. He's a responsible dude. But turns out that it has absolutely nothing to do with how American Express cards are processed, as usual, right? So he needs to call this other guy, and of course the other guy is that drunk. The normal stuff, right? But eventually they kind of try to work the system out, and they find what the problem was. And the problem was, well, they assumed that American Express deals are significantly less amount of the Visa and MasterCard, and they just have a smaller queue. But the customer ran a promotion that when you buy with American Express, you get some crazy benefits, and this queue just exploded, right? And here's the interesting part. This is the biggest difference between Act 1 and Act 2. This, retrospective. They sit together and they try to figure out what went wrong. How this is called? Root cause analysis, right? Root cause analysis. And here is an example, true example from JFrog. you know, for protecting the innocent or maybe the guilty, but still protecting, we kind of censored all the stuff. And I think that Noreen can explain what's going on here.
Yeah, thanks, Baruch. So I work very closely with our customers to make sure they are getting the serviceability what we agreed on. And I think this is one of the examples which I picked. And I know that serviceability is also very close to you guys. And sometimes what happens that a lot of things are under our control, but sometimes things are not in our control, but still we need to provide that service to our customers. And in this example, you can see that it was in the cloud instance where one of the server basically transitioned to the different zone. And what happened that after that, one of the indexing process started taking longer time. So this is the issue happened on 20th May. So you can see that whole RCA date, and we have a ticket ID, then what time the issue reported. Basically, issue started happening earlier, but we couldn't notice. Then as soon as the customer noticed, that customer informed us. And then if you see the total impacted time is approximately 30 hours, which is a lot. So the whole RCA is that one thing which we were talking about since morning is that monitoring, right? And I have seen it in our example that either we have very less monitoring or either we have lot of monitoring where we don't know what we need to act on. So in this example, that MySQL database cluster basically goes into a different zone, and that indexing process takes more than three times longer, and that caused a big significant time delay at customer location. Then incident resolution, which is kind of a part of the retrospective process which Baruch is talking about. And then what we need to do is that what team did it to bring back the service to the normal. So we basically change it to some of the configuration. We don't have to go to all the details, but basically we change the switch to the primary to secondary or secondary to primary and bring back that calculation time back whatever it was agreed. So based on that, in the retrospective process, we also look what we have learned so far. And customer, basically the key is that customer want to know that whatever mistake you did in this time, the same mistake should not repeat next time. So we need to agree whatever we did it. And the other key aspect is that whatever the monitoring. So as Baruch talked about some of the monitoring capabilities, and also we have the Sumo where you can do some kind of a real-time monitoring. So based on that, we enable those monitoring so that next time customer is not telling us what went wrong in their environment. We are telling back that what went wrong and how we are fixing it going forward.
So that was an example of our own root cause analysis. And of course, we picked something not very critical because we want to talk to you. No, I'm just kidding. It was a valid example. And the question is, one of the questions that we are always asked, how can you gather that? How do you know what people saw, how people reacted? And especially if it is a critical incident, things are happening very fast. No one will sit and document what's going on. Oh, this guy got really nuts because that happened, right? No one will write that. So when do we have this information? And of course, the most valuable source of this information are the emails and, of course, as of today, the messenger logs, right? Basically Slack logs or HipChat or whatever you use. That is exactly the good source of information of what actually happened. So, right, and now in our example with Pentagon, it was a queue overflow. And the fix was very easy. We will just prune the queue. Who cares about the stock transactions over there, right? No one cares. And then we need to enlarge it. And now we need to know by how much. And the developer goes like, well, let's double it. Or you know what, let's triple it. That's safer. Triple it, it's good. Like, how do they know? They have no idea. They just guess. So that's still a problem. And this process is different from root cause analysis, the retrospective. Root cause analysis is an internal process. when we gather and investigate what happened. Retrospective is going to the customer and telling them this is what happened. Now, you might think it's as a show-off. So again, getting to the GitLab example that we spoke earlier, GitLab got a lot of publicity points by investigating what happened with their Black Ops live on Twitter. You could follow GitLab and see how they look for the problem and what they do and how they fix it. But except of the positive PR that they have out of it, of being transparent, we learned something very interesting. Customers are extremely forgiving for any kind of problem, critical as it was for the first time. But then they need to know what happened and what did you do so it won't happen again. And they will never forgive you if the same problem, after you promised you take measures to prevent it, happens again. Because it means that you lied, it means that you don't know your technology, and it means that you are unreliable. So first time, delete your primary database and then don't have backups. GitLab, they're still fine, first time. If they're going to do it second time, they're out of business. So this is extremely important, not only for showing off, but for establishing trust between you and your customer. And by then, actually, the customers force you to install those smoke alarms in those places when you had fire. So in those places, at least, it won't happen again. And now we're going to Act 3, which is the tragedy culmination when everybody dies, and it's called the perfect storm. So again, let's set the stage. New in people, round B, a lot of money. 100 developers, 5 developers with operations background, 1 whole performance engineer, like the whole person, like 100%. Right? Chief architect. Systems start to be complicated. Someone needs to see the bigger picture. This is a guy whose job is to see the big picture. This is why they hired. Customer success team. Now you remember that this developer on call had no idea what's going on because he wasn't the subject matter for this particular problem? No more. Now we will take a subject expert, the subject matter expert for every aspect of our system, and chief architect will tell us who those people are, and we will put them on call. And they will hate us for that, and that's fine. By the way, I met a couple of people that actually love doing that. It's kind of, Sherlock Holmes investigating stuff. They enjoy it. Not much. Not many people are enjoying that, and then we just force people to do that because why not? Because we can. Legal. That's this period in the life of a company when they have a legal on a payroll. And it will be a lot of fun, I promise you. CFO, the guy who actually cares about the money and how they are spent. Everybody cares about the money that they earn. This guy cares about money that they spend. A lot of customers, 1,000 customers, big and small. It looks like a very successful startup, and good for them. In process, we're getting involved again. So SAFE is one of those attempts to bring Agile to big teams. This stands for Scrum Scale Application Framework, I think. Yeah. And it's basically Scrum for big teams. We heard mixed results about it. Some people like it, some people don't. But that's one of those things that you can do when you have a 100 developers team. QA, system testing. Chief architect now wants the whole system as a big picture to be tested. Ops. Now this is very strange. You are in a DevOps conference, you are all DevOps, and you should go out of this talk right now, because this doesn't make any sense. It's like we are getting backwards. We just spoke about how DevOps is merging devs and ops, and now we take them in a separate team. And this is because that's not the team that does operations. This is the team that enables all the rest of the company to do DevOps. This is the team that train the software engineers how to become DevOps engineers. Those are the people that advocate that a software engineer should be in charge of their code all the way to production systems. And they know how to do it because they have this ops background. So this is our ops evangelists team, I would say. Escalation path. Now we can build an escalation path because we have support, we have this subject matter expert, and now we have a manager of call who is responsible in some very rare cases and get this escalation out of that. So again, taking JFrog example, our CEO is the endpoint of our escalation chain. Well, it's bad news for everybody if we need to wake him up at 3 a.m., but sometimes he needs to take part of the solution. Not by writing code, he has other means, but eventually the escalation path don't stop at the technical guys. Doesn't stop at technical guys. Well, they are in a financial business, a lot of fun for them, right? A lot of regulations, fun. Non-functional backlog. This is what the performance engineer brings. Said, guys, you need to remember that it's not about functional. There is some non-functional stuff that need to be accounted for. Well, and tools evolve again. Now we have configuration management tools in place and proper APM, right? So Dynatrace right here. There are tons of others, APM tools, all of them good, some of them better. We use New Relic at JFrog. Others are good as well. So here you go, right? And now the action part, the last one. Let's roll. So first of all, we have a new round. It's time for a drink. And then, of course, everybody drank. And no, not the customer. Now, what we have is, which one of that? Yes, the legal guy is calling the head of development and say, so I come back from a legal conference, like the conference of the, the attorneys. It was a blast, such a great talks, intense stuff. Now what I learned is that we are not allowed to use LGPL version 2.2 in production because they told me, the speaker told me that we cannot use it. Do we use it? And then the head of development goes like that, and then because he has no idea, and then he actually asks his developers to go and find out. And they go and find out. They dig into the files, they look at the descriptors, they try to find websites from which the software, the packages that they used were downloaded, and eventually they come with a list. And the funny stuff about this list is that it has this incompatible license, and they have a delivery tomorrow, which of course cannot be done now. Everything is postponed, a lot of fun. Well, more stuff. Now the CFO calls the head of development and asks, I need to build a budget for next year. Do you have any idea how much our cloud AWS is going to cost? And then, of course, the head of development goes like this because he has no idea. And then they guess. They say, we will take our budget for this year, and we will add like, what, 30%? And then we'll have a budget. And actually, who cares? Because even if we break the budget, no one will shut out production services. So we can name everything we like. And then throw some number in the air, and this is how we roll. Sales guy now contact the development and say, guys, I have a customer here, and they say they will have tons of load. So will it scale to this certain amount of load? And of course, the head of development has no idea. So what he does, what they do, they ask the developers. And they go like, the developers, will it scale? And they're like, sure it will scale. We wrote it. It's a great software. Of course, it will stand any scale you want. And then, how do you know? Well, because we wrote it, and our code is great. It's even written in Ruby, whatever. And it's great stuff. And then this happens. Right. So it was a reference to 300, and they all died. They didn't scale. That's OK. Just to make sure that we know what I try to do there. Okay, so, and then more stuff happens. Sales again, with a call like this is ancient Greece, so they got a call from ancient Rome. And they say they want to buy our software, but they need it in an ancient Roman and not in ancient Greek. Can you, is it like translated? And of course, this is what happens. And then eventually, the head of development asks the developers. And the developers like, sure, of course. We did everything by the book. We have translation bundles. We have those properties files with the dictionaries. Everything is absolutely solid. Everything will work. And then they, of course, discovered that Romans used those strange numbers. And no one thought that numbers should be translated because they are just numbers, right? So yeah, anyhow, this is where everybody died. And since we are in America and not in ancient Greece, we cannot leave everything as said. So we will try to make some twist to a happy ending right here real quick. I know that I'm way out of time. But for a happy ending, I think that's like obligatory. And the happy ending, not a lot of teams do that because it's hard, but we believe it's doable. Proactive improvement, that's the way to go. And for that, we can actually fix the problems that caused our perfect storm. Performance and scalability testing guarantees that the question will at scale won't happen again. License and security management guarantees that we know exactly which licenses we have in production and we don't have security vulnerabilities, as Derek told you lengthily this morning. Proactive performance and trends review. Let's see, is our performance improved from version to version, or it actually degrades, or maybe it's stagnating. Non-functional definition of done. This performance guy not only have a backlog, but actually say there is no release until you met those performance goals and non-functional goals, right? And of course, more and more tools to help in the way. So now we have a bigger system, so we need something like mission control to manage our Artifactory instances, X-ray to do this license and security vulnerabilities, recursive scanning, Blazemeter, some kind of performance testing on the run. And here's Derek. I've been complimenting you all my talk. You missed everything. Service virtualization can help here already, right? We're big enough, and of course the rest of the stuff. So how do we fix the problems that we had in previously? How can we fix this license and security vulnerabilities? You can, of course, use different tools, and this is one of the examples. This is our JFrog X-ray, again, shameless plug, very short one. You can analyze recursively stuff like, I have this Docker image, and there is a Debian package inside, and there is a targzeb with war and a jar file inside. This jar file is vulnerable. I can mark the whole Docker image as problematic. Not only that Docker image, but all the rest of the Docker images that have this jar somewhere inside their system. And doing it, of course, not only for Java, for whatever you use, right? How can we know how to manage budget or people allocation? And those are trivial examples. This is Excel, which can help you to do that, right? You just record what people do, and then you have a picture, which is very surprising. Most of the allocation won't go towards a new version, but instead to keeping the lights on, to paying the rent, right? Another view of the same people allocation, we mark them with tags or with colors, and then we know exactly what people do. This is trivial stuff. You can do it now. You don't need any software to do that. All you need is to speak with people and write it down, and suddenly you have great visibility, right? How can you know what budget, how much it will cost? Tools like JFrog Mission Control can do graphs that will tell you how much storage you will use for your binaries, and you will know the price. Will it scale? How can we know that? Oh, that's a great question. How do we know about the quality of our software? Who can tell me? How can we know if our software is good? Thank you very much. Oh, I love you, Andy. Customers are happy. How do you know if customers are happy? Quiet, and if it's not quiet, then it's what? Support tickets, right? Support tickets are a great measurement of whether customers are happy or not. And here's an example, defects by severity. Now, you look at that, and you're like, what the f is going on? 65% of our tickets are S2 and S1. Our system is piece of... Is it true? Well, is there any other explanation of this number considering that our system is not complete crap? There is. The support guys don't know anything. Can we check that? Can we verify that? Of course we can. All we need to do is check the resolution. If most of the tickets were closed by explaining to the support guys that they have no idea about our system is not that bad. We have another problem, which is knowledgeable support engineers, but at least our code is not as horrible as the previous graph showed. So that's very important aspect as well. And epimyth. Who knows what epimyth is? Don't be embarrassed. It's like Google Translate barely knows. Epimyth is the moral of the story. So the moral of the story is very simple. You remember that? Tools, people, and process, and change that happens here when technology, process, and people meet. There are a couple of things that need to happen for this change. And first principle is you build it, you own it. That's the DevOps principle, the most important. Whoever wrote this line of code has the responsibility all the way to production, maintenance, support, and everything else. And this is a very nice statement, but how do you make it happen? And this is my favorite part of this talk. The most important drive to change to DevOps is pain. Pain is instructional. There is nothing better than waking up a developer at 3 a.m. because then he will make sure that he won't be waking up again at 3 a.m. Pain is instructional. And of course, a couple of links. No time for Q&A, but we are right here. That's me on Twitter, Baruch. That's Naren on Twitter. That's our hashtag, DevOps Day CLT 17. Am I right? Yep. And jeffrock.com/show notes have the page for this talk. It has the video. We'll have the video tomorrow. It has the slides. It has all the links that I mentioned with all the tools. There is a feedback form when you can tell me how wrong I am. And there is a raffle. And if you come early, you can double or triple your chances. And SwampUp is our user conference when I want you to both speak and participate. The details are in our table. Thank you very much. And I apologize for running late. Thank you.